So my name is Maxime Martinasso. So I'm working at CSCS. I would like to thank the organizer because I found quite nice to go to the, something different than the machine room where I used to go normally for any kind of visit of HPC centers. So I will talk a bit more about cloud and HPC technology convergence. So I will see the look of cloud versus HPC or HPC versus cloud in terms of technology, and why at CSCS we have to kind of adapt to the cloud technology, and this is because of use cases. Okay, so I will present some use cases. All right, so this is the agenda: cloud and HPC, use cases, HPC and cloud. Okay, pretty similar. Well, you have to converge from one direction to the other. So actually, it's looking at both directions. I mean, of course, HPC and cloud is more, what we're doing at CSCS for this convergence. But first, I want to talk about, a bit of what cloud is and what cloud is doing to provide HPC services. So first of all, I think cloud comes, with a very nice idea of infrastructure as a service, which means that you, as a user, you're not bound to a system. You can define, your system. I mean, of course, the hardware is fixed, but you can say, what I really need in terms of capacity and capability. And on top of that, you can deploy your platform, any kind of platform. And they also provide a very nice set for, functionality for users, So you have this identity access management, which is a nightmare for, for us, for instance, with the legacy of different users. You have full access to the web, very simple interface. You click on Amazon or whatever, you click to button, to command line, say, up, you have your cluster. Also, they have a clear way of paying, or in that sense, I mean, every resource you get, has kind of a price for it in any kind of system, and for them it's very clear. You can see clearly the terabyte per dollars if you want the storage or the node hour dollar. Of course, for our point of view, they have some drawbacks. First of all, they're commercial, so they want to make money. So they don't care about science, the development of science, and in a sense, society. They're just here for making money. Their resources are shared and virtualized, so you never know on what you're running or with who you're running. So for performance is a kind of issue, and that's exactly what happened. So you most likely in classic cloud provider, you don't get a very good performances. You just get capacity, in terms of nodes. But this is changing. This is changing. That's where the cloud and HPC, so the cloud is kind of absorbing, slowly but surely, HPC technologies. And I've put some example. So the first one is GPU. So you remember that GPU came a few years back. I think CSS was one of the first to introduce GPU at large scale. But basically, they're accelerators coming from the computing community, or used for computing, starting with gaming, because in gaming you do a lot of physics, for rendering, and then it became computing. And of course, all of them now have GPU, because they're driven by this AI and machine learning, business. They're making a lot of money with it. They're very happy with it. Now we see that, for instance, I took the example of Google Cloud because I remember I was at AC. I won some pair of socks that I have here now from Google Cloud by just deploying a Slurm cluster. It took me like half an hour following the tutorial, clicking, blah, 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 and then I have my Slurm cluster. It was very simple. I was very impressed by this technology. And it's not only Google Cloud doing it. A lot of them are doing this. Now, since then, we have seen that Amazon can provide Lustre on demand. And that's astonishing for me because, if you know how to configure Lustre, but it's pretty difficult. It's not something, you deploy like this. It's quite complex system. You have, different IO node, OST, OSS nodes, and you have to do the routing of the striping of files. Now you click, you have it. And I think that's quite impressive. And furthermore, we have seen that Microsoft acquired a Cray system. So now they have in-house, on their cloud, a Cray system, the same as CSCS has. Of course, they are not completely virtualizing it and providing, very nice, easy things. It's still, I would say, customer-based, and they have 3 systems, but they have XE system with Lustre that you can acquire, for a short period of time on the cloud. So you can see that the cloud people, I mean, the main providers, are slowly but surely integrating HPC technology. And I think we should do the same on the reverse, okay? So, but first of all, what is different for our mandate from the cloud? I mean, we are providing high-performance computing capabilities. Basically, you can summarize it by having a very, thousands of nodes, very powerful nodes, a lot of memory, strong CPUs, accelerators with it, okay? And on top of that, for connecting all of those nodes, you have a very fast, specialized interconnect. Then that allows you not to lose too much in communication versus computation. So communication remains fast. So that's the compute part and network part. Then there is storage. We also provide, a lot of different storage. So we have classic Lustre, high bandwidth, write bandwidth actually, parallel file system. We have some near compute fast SSDs. So like if you take the Cray machine, you will not have SSDs on the compute node, but you will have blade full of SSDs connected to the same network as the compute nodes. Okay. We have a kind of system-wide file system, like you can imagine having a GPFS running that you can access your application from different clusters or different systems. And, sorry, wait, I'll press this button. And you have archive storage, okay, with tapes, more likely. And the goal for our goal, is not here to make a lot of money, sorry, but is to really be a scientific device, for scientists to get, to reduce their time to solution for the application and have more science throughput. That's, I think, if I'm right, Michele, that's more or less our mandate.
Yes. Still, we need some monitoring.
Yeah, exactly. Yeah. All right. That is true. We have CSCS to go to. Anyway, so use cases. So why are we, looking at this cloud technology from an HPC perspective? So I will present 3 use cases. I think one has been presented this morning, but okay, why not? So SDSC, so the Swiss Data Science Center. So as I said before, they have a mandate to provide a nice framework for doing data science, and with different, particularity like reproducible usage of the data, communication between the different partners. And this is called Renku, okay? So it is interactive, so it spawns, Jupyter notebooks to the compute nodes, and there is a workflow system where every step is stored in the common workflow language. If you need to, to reproduce a workflow or provenance of the data, things like that. So data now is managed, so if you have